Module 5 is on the alkenes and alkynes. We will start with a brief overview of the alkenes, what you already know about the alkenes, and then we will look at the naming of alkenes and a few examples of questions. Then we'll move on to the alkynes, again just a brief overview of what you already know about the alkynes. Then we will look at the naming and do a few examples of questions. The functional group for an alkene is at least one double bond between carbons in the molecule. We know that alkenes are unsaturated hydrocarbons because of the double bond, and we also know that this makes the alkenes much more reactive. When it had to react, for instance, with the bromine water, you saw that it quickly reacted with the bromine water. And the general formula for alkenes is CnH2n, so there are always double the amount of hydrogens compared to the amount of carbons. In our example here, we have 4 carbons and 8 hydrogens. The name of an alkene will always end on an ene to indicate to us that it is an alkene. Now we need at least 2 carbons for a double bond between the 2 carbons. So there is not something like methane. We start with the second stem name, which is F, and you will see that the stem names are exactly the same as the stem names that we used for the alkanes. So F is the stem name that we use for 2 carbons, and the ene indicate to us that there's a double bond between the 2 carbons. Prop, 3 carbons, and the ene indicate to us that there's a double bond between 2 carbons. But we are faced with a problem when we get to 4 carbons, because which one of these 2 molecules is butene? Both of them have the same molecular formula of C4H8, but you can see that the functional group, the double bond, is at different positions for these 2 molecules. So we call these 2 molecules positional isomers because their functional group is at different positions. But we still have to distinguish between the 2 molecules. So we write down the number of the first carbon in the chain that has a double bond. So for the first molecule, we have a double bond on the first carbon if you number from left to right. If it was from right to left, it will only be on the third carbon. So we rather number from left to right. And therefore, we use the name but1ene for this molecule. The 1 tells us that there is a double bond on the first carbon. And remember that you have to separate numbers and letters with a hyphen. The name for the second molecule will then be but2ene. The 2 tells us that the second carbon, if you number from left to right, has a double bond on it. If you number from right to left, you will get to the same name in this case. So it doesn't matter if you number from left to right or right to left. The name of this molecule is but2ene. So for the stem names of 4, 5, 6, 7, and 8 carbons, you will have to show the number of the carbon that has the double bond on it. So pent1ene has a double bond on the first carbon if you number from right to left. Hex1ene has a double bond on the first carbon when you number from right to left. And the same for hept1ene and oct1ene. There are just a few minor adjustments to some of the rules when we name alkenes. So the first rule is still to find the longest continuous chain of carbon atoms, but you have to now include the double bond in that longest chain. So for this molecule here, the longest chain that includes the double bond will be 5 carbons. So the stem name will be pent, and because there's a double bond, we use ene at the end of the name. The second rule is still to number the carbons in the longest chain, but now the lowest number must be on the double bond. So if we look at this example and we number the carbons from right to left, you can see that the first carbon with a double bond is carbon number 3. But if you number it from left to right, the first carbon with a double bond is carbon number 2. The third rule is to identify and number all the alkyl groups. So we have 2 alkyl groups and both of them are methyls. So we have a methyl at carbon number 2 and we have a methyl at carbon number 3. And then rule 4 still applies. If there are more than one identical substituent, we still use the prefixes di, tri, or tetra. So in this case, we have 2 methyls at 2 and 3, then the name is dimethyl at 2 and 3. Now we are ready to write down the name of this molecule. The stem is pent, the -ene to tell us that this is an alkene, but we have to say that this double bond is on carbon number 2. So we use a 2 to show that the double bond is on carbon number 2. And then we have to write down all the substituents or alkyl groups. There are 2. It's a dimethyl at carbon number 2 and 3. So the name of this molecule, 2,3-dimethyl pent 2-ene. One word, commas between the numbers and hyphens between the numbers and letters. Dienes are not in the CAP syllabus, but I just quickly want to show you how they work because you often get examples of dienes in some of the textbooks. Dienes have 2 double bonds. So this molecule here is a diene. And then we have to show where those double bonds are. So if you number this molecule from left to right, on the second carbon you have a double bond. If you number it from right to left, you have a double bond on the first carbon. So for this molecule, we will number from right to left. On the first carbon and the third carbon, there are double bonds. So the name of this molecule is pent 1,3-diene. The di tells us that there are 2 double bonds. The first example. The longest carbon chain that includes the double bond is 3. So the stem name is prop. The double bond is the functional group of the alkenes. And the first carbon with a double bond is carbon number 1 if we number from right to left. If we number from left to right, the double bond will be on carbon number 2, and that is why we have to number from right to left. There are no substituents, so the name for this molecule will be prop 1-ene. If the question is given to you as a condensed structural formula, rather draw the structural formula because then it's easy to name. The longest carbon chain, including the double bond, is 4. So the stem name is but. The double bond is the functional group for the alkenes. The double bond is on carbon number 2. It doesn't matter if you number from left to right or right to left. The carbon with the double bond will be carbon number 2. There are no substituents, and then the name for this molecule is but-2-ene. In this example, the longest carbon chain that includes the double bond is the chain that goes around the corner. So the longest chain is 5 carbons. The stem name is pent. The double bond is the functional group for the alkenes. The double bond is on the second carbon if we number from right all the way to the bottom. If we start to number from the bottom, then the first carbon with a double bond will be carbon number 3. So we have to number from the right, and the first carbon with a double bond is carbon number 2. There's one substituent, and this is a methyl, and the methyl is on carbon number 3. So the name for this molecule is 3-methyl pent 2-ene. One word, hyphens between the numbers and letters, and no spaces. In this molecule, the longest carbon chain that includes the double bond is 5. So the stem name is pent. The double bond tells us that this is an alkene. The double bond is on the second carbon if we number from left to right. If we number from right to left, it will be on the third carbon. So we have to number from left to right. And then there are 3 substituents. All 3 of them are methyls, and they are on carbons number 2, 4, and 4. So the name for this molecule is 2,4,4 trimethyl pent-2-ene. Again, a rather confusing condensed structural formula, so let's rather draw the structural formula. The first carbon has 2 hydrogens, and then a carbon with a methyl group, and also a carbon with 3 hydrogens. So we need a double bond on the first carbon to have 4 bonds on that carbon. 2 hydrogens, and then a double bond to another carbon. And then 4 bonds on this carbon, 4 bonds on that one, and then the molecule is right. Okay, so this molecule is easy to name. There's the double bond. The longest carbon chain is 3 carbons. The stem name is prop. Double bond is the functional group for the alkenes. The double bond is on the first carbon. There's 1 substituent, a methyl, on carbon number 2. So the name for this molecule is 2-methyl prop-1-ene. Draw a structural formula for 2,3-dimethyl-but-2-ene. The stem name is but, so there are 4 carbons in the longest carbon chain. There's a double bond on the second carbon. There are 2 alkyl groups, both of them are methyls, on carbon number 2 and carbon number 3. And then we complete the molecule with single bonds and hydrogens. So there are 4 bonds on each carbon. Write down the molecular formula for hept-3-ene. Hept, there must be 7 carbons, and we know the general formula for the alkenes is CnH2n, so there must be double the amount of hydrogen, so it's C7H14. A quick recap on the alkenes. So the functional group for the alkenes is at least 1 triple bond between carbons. Alkenes are also unsaturated hydrocarbons because of this triple bond. They are very reactive because of the triple bond, and the general formula for the alkenes is CnH2n-2. So if you take the amount of carbons, 4 multiplied by 2 gives you 8, subtract 2, and that gives you 6, and that's the amount of hydrogens. Naming of the alkenes exactly the same as the alkenes. You just use YNE as the last part of the name. So you need at least 2 carbons for a triple bond between them. We don't use meth as a stem name for the alkenes. We start with 2 carbons, so it's ethyne, and then propyne for 3 carbons. Similar to the alkenes, when we get to 4 carbons, we have positional isomers where the triple bond can be on carbon number 1 or carbon number 2. So we have to distinguish with the name that the triple bond is on the first carbon or the second carbon. So with the triple bond on the first carbon, we will have a name of but-1-ine. So for the alkenes with 5, 6, 7, or 8 carbons, we use the stem names pent, hex, hept, and oct. In this example, the longest carbon chain, including the triple bond, is 2 carbons, so the stem name is F. Triple bond is a functional group for the alkenes, and the triple bond will always be on carbon number 1 if there are only 2 carbons in the molecule. So it's not necessary to show that the triple bond is carbon number 1, therefore the name for this molecule is ethyne. The longest carbon chain, 3 carbons, so the stem name is prop. Triple bond is the functional group for the alkenes. The triple bond is on carbon number 1 if we number from left to right. There are no substituents, so the name for this molecule is prop 1-ine. The longest carbon chain that includes the triple bond is 6 carbons. So the stem name is hex. The triple bond is the functional group for the alkenes. If we number from right to the bottom, then the triple bond is on the first carbon. There are 2 alkyl groups, both of them are methyls, on carbon number 3. So the name for this molecule, 3,3-dimethyl hex 1-ine. Draw a structural formula for 4-methyl-pent-2-ine. So the pent is the stem name. There are 5 carbons in the longest chain. There's a triple bond on carbon number 2. There's a methyl alkyl group on carbon number 4. And then we complete the molecule with single bonds and hydrogens so that there will be 4 bonds on each carbon. Write down the molecular formula for ethine. We know that the general formula for the alkenes is CnH2n-2. So F tells us that the stem name is 2. There must be 2 carbons. Double the amount of hydrogens minus 2 gives us 2 hydrogens as well. So the formula is C2H2. If you are an educator that would like to inquire about the use of these PowerPoint slideshows in your classroom, you may contact me at lawsandwonders@gmail.com. Please indicate if this topic was useful to you or not, and subscribe to my YouTube channel in order to stay informed about the release of my most recent videos.